or builders, please email your talk proposals to us, owasplondon@owasp.org. Okay, now again, a reminder that you can ask live Q&A questions using this app, Slido Do. So please take your mobile phones and make sure you are ready for Q&A. Now, it's my great pleasure to introduce Jeff Williams. Now, he's always the most visible person in the room because I think he's taller than everyone else. But obviously, this man is an absolute legend because OWASP was actually founded by Jeff many years ago. And 17 years ago, when people were only starting to understand the risks and vulnerabilities around web applications, Jeff was basically at the forefront of all these issues, putting together OWASP Top 10. So Jeff has been a board chair for many, many years after creating the foundation, because he basically converted OWASP from being just a mailing list and a virtual kind of organization into organization we have today with 45,000 volunteers and 200 countries participating. Of course, OWASP Top 10, I'm told there's an urban legend which turns out to be true. So I heard that OWASP Top 10 was created by Jeff when he was in the shower. And I asked Jeff, it turns out to be true. So basically the story is Jeff went to a meeting with a whole bunch of executives of the company, and they were trying to sell application security concept to them, right? So this is like 2001 we're talking about, right? And no one could understand. It's like, oh, there are just way too many risks. And it's like we can't get our head around this. And yeah, we need like top 10. And when Jeff was in the show, so okay, we'll give them top 10 and we'll call it OWASP Top 10. So this is how we have OWASP Top 10 these days, right? So many thanks, Jeff, so for a brilliant idea that now obviously everyone in the world is using Top 10. Now, WebGoat, who in the room is using WebGoat? You see, almost everyone, right? So I'm pleased to say that it's Jeff's baby. And obviously enterprise security API is, again, one of the projects that Jeff created. And I think this sign was originally designed by Jeff as well. And I think almost every single project here, Jeff is a contributor. So it gives me a great pleasure, Jeff, to welcome you here in London. So yeah, it's all yours now.
Okay, this working? That sounds good. Thank you, Sam. That was a wonderful introduction. I appreciate that. And you want me to hit share on this?
Yeah, select what you want to share. Share button.
Share not.
Yes, yeah, we can see. Cool.
I don't want to share that. I want to share this. Okay. Let me. Oh, and did you leave your power up here? Oh. So I need some nice British power. So thank you very much, Sam, for the great introduction. Thank you to Just Eat for having us here and having drinks. It's wonderful. And thank you for the pizza. That was easily the best British pizza I have had in a long time. I don't get to England very often. I have 4 kids at home, and so you know, even while I was helping to create OWASP and starting chapters all over the world, I never visited any of them. So this is actually a real pleasure to come out and see you guys, and the turnout is amazing. I want to thank you all for coming out and being part of the OWASP community. It's actually really important that you guys participate and hopefully become contributors to OWASP. We are just barely scratching the surface of application security. I've been doing this for 25 years, and we are in the Stone Age with regard to application security. I'm going to show about 3 slides that are, I think, terrifying about sort of where we are, and then hopefully I'm going to try to present a vision for where we might go and how we might be able to make it better. But look, I've been through, so when I started my career, I was a software developer. I worked on a bunch of different projects, and we used formal modeling for security. We actually mathematically modeled security in large systems. I mean, it was a ton of work. Didn't work, right? It's way too complicated. It didn't scale at all. So then, you know, later on, we started doing things like penetration testing. had a whole bunch, and that doesn't really scale very well either. We looked at maturity models. I wrote the ISO standard SSE CMM as an idea for advancing security, and it doesn't work. It doesn't scale. It's like too heavyweight. Now we got different maturity models like OpenSAM and things like that. I'm not a huge fan. I think they're kind of backwards looking. We've tried things like threat modeling and security architecture and code review and on, and we're not making any progress. We've really got to think hard about what we do to improve application security, and you guys can take leading roles in what happens with AppSec. Software is amazingly powerful. It's moving forward at an unbelievable rate, and there are huge opportunities. It's like we just discovered the ocean, and we got to go explore all the nooks and crannies. We know very little about how to reliably write secure code. So this talk, I'm going to talk about the 3 ways of security, and this is modeled after the 3 ways of DevOps that Gene Kim, a good friend of mine, talks about in his book, The Phoenix Project. Has anybody read Phoenix Project? Great. This talk's going to be very easy for you guys to latch onto. For the rest of you, go read it. It's really, I think it's an important work, and it's a fun read. So a couple terrifying slides. First off is really, today's security is a disaster. So when I wrote the OWASP Top 10 in 2002, I had this idea. I was like, okay, well, we'll write down the risk. I actually thought it was late, by the way. I'd been doing AppSec for a number of years at that point, and I was like kind of writing down, I thought it was too late to have a standard like that. I thought like everybody knows everything about AppSec already. So just give you a perspective, like right now is really still the beginning of AppSec. But I wrote this top, and I thought like, okay, well, I'll write down the top 10 things. There's like 100 things or 200 things, but I'll just write down the top 10, and hopefully, in a few years, we'll knock a few of them off the list. And we'll write another list that's like, keep moving the bar up over time. That's how we'll get better. Awesome. That didn't happen. OWASP Top 10 is still essentially the same as it was in 2002. There's move a few things around and so on, but actually it's funny, like the access control one is now back to the way it was in 2002. So it's shuffling deck chairs a little bit. I'm not actually really very excited about the top 10. That was a throwaway project for me. I thought like, well, it's like kind of a marketing kind of thing. I don't think that's actually the right, it's not the limit of AppSec. It's not actually even really a great way to think about it. What it is a way to get more people involved. So if you run into people that don't know anything about AppSec, it's a great way to say, hey, look, here's these 10 things. Just think about doing these as a starting point. So that's kind of what I think it's useful for. This is a problem. So the average application out there today has about 2 million lines of code. 21% of that is libraries. That's going to be a problem. So 21% of that is libraries. Is custom code, and the other 79% is libraries. What's interesting about that to me is that only 8.5% of the application is actually libraries that are invoked. The vast majority of libraries are never called at all. So we read a lot about library security. Equifax was a bit caused by that problem, and it's got a lot of press right now. But I want you to keep it in perspective. A lot of this talk is about keeping things in perspective. So most of that library code is unused. And look, there's only a couple of vulnerabilities in every app on average that come from insecure libraries. So they're important. Don't forget them. But they may not be ever used, which means you're not vulnerable, and they're only a small percentage of the vulnerability in the application. Now this top piece, the custom code, that's where the vast majority of vulnerabilities live, 26.7 vulnerabilities on average. So this gives you sort of the lay of the land, but what's terrifying about this to me is that is way too many, by like orders of magnitude. Can you imagine if we were flying planes around that had 26.7 serious safety defects? That would be nuts. The airline industry doesn't tolerate that kind of crap. And we need to be better. We can achieve those kinds of numbers in security if we get serious about AppSec, but we're not serious about it. Most companies don't take it very seriously. And so we end up with this situation, and we keep chasing our tail. We keep pointing out, hey, you're vulnerable, better fix it. And they go do that, and then they introduce more, and we're not making progress. So it's been like this for 20 years. And we're not, unless we do something different, it's going to stay like this for another 20 years. And that's going to be really bad because applications are getting, I think of this as sort of the 3 C's, the perfect storm. They're getting more critical. So we're doing more important things with them, with money and defense and finances and so on. They're getting more connected and they're getting more complex. All those 3 things are bad for security. And so, looking forward, this situation is 26.7 bad now, yeah, but tomorrow it's really bad and people are going to start getting killed. The second thing is that software is leaving security in the dust. So, when static and dynamic and WAF tools came out in the early 2000s, there's a lot of research going on then. We had simple web applications and those tools were sufficient. But in the meantime, software has exploded. I knew we were in trouble in like 2007. I saw my first single page app with a JavaScript fetching from a service on the server side. And I couldn't intercept it with, I think it was WebScarab at the time. Now it would be like Burp or Zap. And I just get all these pop-ups, all these intercepts. Oh, so I'm like, how am I going to test this? I got to write automation just to test this app. And then since then, it's been just an explosion. APIs are incredibly hard to test with those legacy tools. The move to the cloud has introduced the speed and complexity of apps. But probably the biggest change is, well, there's the explosion of frameworks and libraries and stuff. Now we've got like 200 libraries per app. There's a lot. But probably the biggest change is the move to DevOps. And the speed of software deployment has increased so dramatically that I spent a long time being a security expert, doing code reviews and pen tests, but I can't fit into a DevOps pipeline that's deploying 6 or 7 times a day. So in that sense, I'm the problem, right? Experts in the development pipeline is the problem. So we've got to figure out how to change ourselves. As security experts, we've got to change from being experts in the critical path to coaches and toolsmiths so that we can get out of the critical path and allow software to flow into production immediately without having to take weeks or months to get secure. And the last thing, and these are just 3 sort of random points to demonstrate the situation that we're in. I could go on these, the problems with the way software security is for a long time, but I don't want to waste my time doing that. But this one I think is actually really important. Software supply chain is totally broken from the ground up. It's not just Equifax and using libraries with known vulnerabilities. It's the fact that those libraries are produced with almost no assurance. Anybody out there in the world can write an open source library and publish it and put it out there for people to use. Companies are betting their future on those libraries. And we don't really have very good assurance in them. But if you think about any other industry with a software supply chain, like the pharmaceutical industry or the automobile industry or Apple, they've got incredibly well-developed QA across the whole supply chain to make sure that they can deliver high-quality products on time. We have nothing. We don't even have a notification mechanism, so if someone discovers a vulnerability in some sub-library of some sub-library, no one gets notified. That's bananas. If you look at Equifax, that vulnerability came out on March 7th. By March 8th, we were observing widespread attacks from a whole range of countries, targeting broad ranges of IP addresses, just random scans. That attack was actually an expression language attack. The deserialization flaw came out later. That's 2 major vulnerabilities in Struts 2 within a span of a few months. But this first expression language attack was really simple. 1 HTTP request with 1 content type header that has an expression in it. That's it. When that request arrives at any application running Struts 2, Struts 2 said, whoa, that's a weird content type header. I'm going to generate an error page. And they take the contents of the content type header and they put it into the error page. And as part of rendering that page, they evaluate the expression, essentially running the code inside the expression. Boom, complete host takeover with 1 HTTP request. You can write a little curl script of 3 lines to spam the internet with that almost immediately. And that's what we saw happening. So essentially, companies had less than 1 day to protect themselves. Anybody think their company was protected against this within a day? Now, the outrage about this vulnerability was crazy. People went bananas, like, how could this happen? Well, every single company I know of has this problem. They cannot respond in less than a few months to something like this. It takes them time to find this vulnerability, it takes them time to replace the library, rewrite their app to meet the new library, retest it, redeploy it, resecure it. That takes time. And so this is a serious challenge for us. I think this needs to be, we need to do what we can do to prepare for this so that we can respond within hours. Next year, year after that, it's probably going to be minutes. So I think this is really a big challenge for AppSec. Okay, so let me sum up. If you think about diagnosing the problems with AppSec, I want you to imagine your application portfolio. This could be tens or hundreds or thousands of applications, depending on the organization you work in. But when you look at what we're really delivering, we do scans on these applications every once in a while, and you get like this little strobe light visibility into what's going on in one of the applications. And at the end of the year, we've probably only looked at like 10% of our application portfolio. That's pretty typical. Anybody got an organization where they only look at the critical applications and don't really do much with the rest? Liars. So at the end of the day, we're delivering this. Like, we're delivering the assurance that, well, I ran some scan, right? Not very good assurance. We need to be delivering something totally different. Oh, and by the way, we're wasting a huge amount of time to achieve these results. I've seen apps that are being tested for SQL injection that don't have a database. That's probably not going to work. We need to be a lot smarter about what we're testing in the application. So I want you to think about a different result. What security should be delivering? This is the whole application portfolio. We need to be delivering assurance that all the right defenses are in place, that those defenses are effective, like they actually work, they're correct, and that those attacks are, any attacks on those applications are detected and blocked. That, to me, is a pretty reasonable assurance case. Now, here's the point of this talk. If we identify really clearly what we're trying to deliver, we can do it much more efficiently than we're doing it today. We can use the techniques of DevOps to achieve this result much, much faster than we could do any other way. And so that's kind of where I think we need to go as an industry, is focus on what we're trying to deliver and deliver that value really fast. So let's talk about how we get there. Just to introduce DevSecOps, this didn't go over at all before. So this is an American Super Bowl commercial, Puppy Monkey Baby? No? Okay, never mind. In my head, that is really funny. So, no, it's over. The moment's gone. It's gone. We'll move on. So I'm going to take a second. For those of you who don't do DevOps or haven't really experienced DevOps personally, we're a DevOps organization, so we deliver code 6 or 7 times a day. But not everybody's really experienced it. And you may get the wrong sense of it from reading articles online. People talk about automation, they talk about pushing left, they talk about merging dev and ops somehow magically. I think really, and I'm not going to try to summarize, I'm not going to try to tell you the Phoenix Project story, because that's the best way to learn about this. But I'll say, when you read that book, look for the 3 ways. It's sort of the core theme throughout the book, but the first way is to focus on establishing workflow. It means you're getting the work. And for security, this would be like those things I just said. The defenses are in place. Delivering that work and getting it flowing through the organization so that it's broken up into little pieces. The work is moving on, through the organization. It's not heading backwards, things like that. The second thing is to create instant feedback. As you're doing that work, you don't get far off the rails, right? You don't introduce a problem here and then 6 months later discover the problem and try to fix it. You're continuously checking to make sure that you don't go far off the rails. And then the last piece is the culture of experimentation and learning. And this is probably one of the most critical things for security, is to create that security culture. And I think the idea of this is how we achieve an organization that can advance its security, right? Not just doing compliance checkboxing things, but actually thinking hard about how security ought to work and getting to that point. So with that summary, that's kind of a theoretical or like a scholarly kind of thought about DevOps. To me, this is what DevOps looks like in my head. I mean, this is not what it looks like in my head. Never mind. But I like this picture because it kind of shows, small batch sizes moving through an organization, and instead of trying to do like big chunks of work all at once, here we've broken the work up into little tasks that can flow through the organization, and at the end we produce awesome software. It all comes together. But you can imagine like feedback loops here, where if things go off track, they get corrected and reinserted. It's fun to look at, isn't it? These guys are like, we can have, if there's a problem, you can swarm on that problem and fix it. You can optimize your work for downstream consumers. This is like, how do you organize the machines in your factory so that the work really nicely flows from one to the next? A good example of how we fail at this in security is PDF reports. We are not optimizing for downstream consumers of our work. When we hand them a 500-page PDF report, that is almost unusable. So if we think about how the downstream consumers want to consume security, we'll deliver it in far different ways, okay? So just a few examples, but to me, this is like how DevOps is. All right, so the question then is, can DevOps help security? In software, the problem was, poor quality, we're late, slow, it doesn't provide business value. That's what we're living today, and or we were living. And then, DevOps really, I think, is a powerful solution. If you look at the metrics for projects that practice DevOps, they're amazing. Here's just a few of them. 5 times lower change failure rate, things like that. And so the question is, can we do something like that for security? Here, if you think about the problems we have with security, it's exactly the same, right? We're poor quality, we're late, we're slow, we don't provide business value. That sounds kind of familiar. So maybe, just maybe, DevOps is an interesting approach. Now remember, I've been through a lot of, I thought that the SSE CMM was the solution. I thought that formal modeling was like the solution to security. So I could be wrong about this too. So let's just take it one step at a time. But if we think about what we want to try to achieve, wouldn't it be great if we could 10x the portfolio coverage, like actually cover all the apps in your app portfolio? Reduce vulnerabilities by 80% that make it to prod, right? Somehow in our process, we want to eliminate those vulnerabilities. And what if we could do it without adding time to market? Those are all really interesting, powerful metrics. If we could achieve that, then we know we've succeeded. So, so how does that work? Okay, that would be great, Jeff. Explain that. So first, I got to say a couple things that I think it's not. And I'm pretty sure that DevSecOps is not just taking traditional application security activities, things like static analysis and dynamic scanning and pen testing and WAF, and just shoving them into DevOps. I don't think that's going to work. A couple specific problems. I see a lot of organizations trying to do DevSecOps, and they take a scanner tool and they add it to their CI/CD pipeline, right? So now as they're doing their build, they're invoking the CI/CD tool, the scanning tool, and it runs a scan and it delivers some results, and then they continue. To me, automating the scan button is not really the hard part of this challenge. That's not really helping us. We're going to run a scan. We're going to generate a mountain of false positives, and then a human has to come in and review this, an expert. And so we've eliminated all the benefit from what we tried to automate. Automating is like no experts involved. If it's not no experts, it's not going to scale. And the other thing is I hear a lot of people talking about pushing left. Anybody push left, do security early in the software life? Well, it's not a terrible idea. Security is way cheaper early in the life cycle, right? Like if you can fix it in dev, it costs a lot less. And there's these neat little charts that show how much cheaper things are to fix in development. By the way, that chart is really misleading. It is not a smooth curve. It looks like, oh, look, it's it's 1x in dev and it's or in requirements, and it's 10x in dev, and it's 100x in production. That chart actually goes up, like 5 minutes after the developer commits the code, the cost of fixing that vulnerability goes up dramatically, right? So it's like this really bumpy curve, actually, if you get into it. But the idea of pushing left isn't realistic. If you just take these kinds of activities and push them left onto the developer, well, these are not activities that developers can do for the most part. These are expert security activities. We need to do, if we push left, we got to do something different. We can't just have the developers run the scan. I mean, that would be convenient for security people. Yeah, developers, you just scan. That's not going to work. We got to change the work if we want to achieve better results. So, now I'm going to try and interpret the 3 ways for security, right? And so if you think about, and this isn't really DevSecOps. Like really, what we're doing is we're applying DevOps concepts to the process of building security. And so I'll just go through the 3 ways, right? The first is establishing security workflow. Like we got to figure out how to get that work flowing, because right now it doesn't really flow very well. Second, we got to figure out how to give instant security feedback. Right now, our security feedback comes way too late. And the last is how do we build that security culture? So we're going to dig in. I've got 3 ideas in each of these categories that I'm going to talk about, but these are not the only ideas. These are just a few potential ideas. Hopefully it gets your brain thinking about this, but there's a lot of research and work to do to flesh these concepts out. All right, so let's talk about the first thing, getting security work flowing. We got to pause here for a second. We got to talk about like what is security work? Anybody know? Like what do we deliver? Well, what's the value that security produces? What do we generate? At the end of the day, when you leave work, what do we hand over to the customer? Say again? It's a weird, that's not really very tangible, is it? Like reducing risk, we produce literally negative something. Comfort, also not very tangible, is it? Yeah. Those are concepts for sure. That would be nice if we could deliver those, but how do they manifest themselves? Like, or who do we hand them to? Yeah, how do we communicate that with the people that need it? I might know there's less vulnerabilities, but how do you know? It's a complicated problem what security actually delivers, and it's kind of a symptom of what's really wrong with security. We're not really delivering anything. So let's talk about the work here. Yeah. No. I mean, what are we delivering, or what should we be delivering?
The answer to the question you just asked, would it not be different 10 years ago versus what it is today?
I don't think so.
What would the answer today?
So today, I really don't think we're delivering very much value at all. I mean, you saw my chart. I put up a box full of like.
Very honest, because the sending invoices and people are paying them.
I understand that. I get it.
By the way, I agree with you. I agree with you 100%.
Look, I'm not saying that that the work that we do is not valuable. It's really hard. Some of the smartest people I know are in doing security consulting. But think of it this way. Imagine we were fighting malaria or polio or something. We could have tons of really smart doctors out in the field treating people individually and making zero progress against malaria and polio in general, right? So when I think about security, I'm thinking about the public health version of security. Like, how do we as a nation and a world get better at security and eliminate some of these flaws forever? I want to, wipe polio off the face of the planet.
That's why I asked the question.
Yeah.
What the answer would be 5 years ago, 10 years ago.
No, it's the same.
10 years ago, it's not what it is today. Today we have so many new threat vectors with terrorists, with destruction motivation, nation states hacking for changing the direction of other nations. Guess what? These are potentially catastrophic.
Sure.
We didn't have that catastrophic value maybe 10 years ago.
Yeah, well, either way, we weren't producing what we should, right? Like it's essentially the same. In my head, it's kind of the same thing, regardless of the threat. It's, you know, I feel like we should be delivering assurance, and we're not. And so let's spend a second. I'm going to come back to that thought in just a second, but let's talk about exactly what the work is, right? Like the things that we do in security. So there's I think there's 4 categories of work. The first thing is things that provide business value, like the things the business actually cares about. Typically, this is things like compliance. It's things like, you know, key security controls that we are defenses that we actually build and deliver. That's the first category of stuff. And remember, we got to get all of this work flowing, right? So it's useful to just say, hey, here's the categories of work we got to plan for and figure out how to deliver fast. The second category is what I'll call internal security projects. These are things that, you know, we do them all the time, but they never see the light of day. They're like, you know, scans and vulnerability assessments and threat modeling and things like that. Like those are internally consumed things that we got to build and deliver as part of our work. The third thing is operational security work. And this is patches and threat monitoring and you know, event handling and things like this. Application security in operations is pathetic. I don't know any companies that really have good visibility into how they're being attacked, who's attacking them, or what systems they're targeting. Because there aren't good sensors to detect those attacks, we don't know. You can look at WAF output, but it's super noisy and it over-reports tons of things that aren't really attacks. So the value gets demolished. We need to be much better in operations. I spent most of my career working on the dev side. I thought that if we just eliminate the vulnerabilities, we can push those apps to production, and I don't really care what happens in operations. But after 20 years, I'm starting to think maybe we're not going to be able to deliver perfect code every time. So I've opened my heart and my mind to security in operations. We need much better sensors there to detect attacks, to give visibility into those attacks, and to block those attacks so they can't succeed. It is, you know, we are tremendously weak on this side of things. We're only a little bit weak on the other side. So we got to do that. And then the last piece is what I'll call unplanned security work. This work happens all the time. Like Equifax is a good example, but these kind of unplanned things happen all the time. A new requirement comes down, new PCI standard comes out, you know, whatever, new attack, new library, whatever. So just understanding this work is really important. I want you to think about breaking this down and figuring out who's going to do it and how you can actually deliver it. Okay, so now we're into the first way. So that was just like, what is the work? We got to understand that. But let's talk about the first way. How do we get this work flowing? So here's 3 ideas. The first is create a concrete security story that evolves over time. Now the idea here is, you know, if you think about the deliverables that we have in security, things like security requirements and test cases and user stories and threat models and architecture and all those things, they're exactly the same. They're all really different views of the same thing. Like if I chose one topic like clickjacking, right? I could just write it once and say like, here's what we do about clickjacking, and it covers all of those things. But we create all these different deliverables and they're not in sync. So anybody got a secure coding guideline? Okay, if I helped write that, I apologize, but those documents are not effective. Every developer I talk to is like, yeah, I think we got one. Never read it, not a chance. We're not delivering. We need a security story that brings together all those views consistently. What we want to do is, you know, and so security story to me, it maps the threat model. So what do we care about to our security strategy for that threat, like for each of those threats. And you know, different strategy for different threats. And by the way, there are multiple different strategies you can choose for clickjacking and XXE and other things. Then there's the actual defense that we choose. How are we going to implement it? What library are we going to use? What product are we going to use? And then there's assurance that that thing is right. If we have that line of sight, I can have a pretty confident discussion that I've addressed that. And we'll talk about an example of that in just a second. But this idea of having a security story, it has really good effects on your culture. It enables communication. So if someone asks you, how do we defend against XXE? Oh, Well, we do this. I'll tell you in just a second how you do that. It aligns everyone in your organization around this team, and it allows you to evolve. You can go to that document and you can look at it and you can say, well, looks like we got a pretty good story for A, B, and C, but what are we doing about SSL versioning or something? And you can just choose a threat, choose the things that are most important to you. Right now, when we do security, we do everything in security, from the most important stuff down to like the 150th most important thing, like log injection, or using system out print line. Anybody seen that from a static analysis tool? It says you're using system out print line, that's not an appropriate logging method. Guess what? No one has ever been breached because of that flaw, not in the history of the world. So if you're dealing with that before you deal with command injection or something, you are bananas. So look, we got to deal with the most important things first. So this is a very agile way of thinking about things, right? Like if in agile development, you choose an important story to the customer and you deliver that all the way through. Well, we need to do that with security. Let's pick our most important risks and do that all the way through. Strategy, defense, assurance, the whole thing, deliver it, and then move on to the next thing. That's a very agile way of thinking. I think of it as vertical security, like you do the most important risks, as opposed to like inch deep and a mile wide security. So this first thing, capturing your security story, is important. If you want more information about it, you can go to the Rugged Software Project. We've talked a lot there, some documents about how to build a security story and what should go in it. The second thing in the first way is enable development to build security. So I want you to imagine breaking down security tasks from, like a big architecture review or a big scan or something. Break that down into little tasks. And then most of that work can be done by your normal processes. If you define it well, developers can do most of this. I'll give you an example in the next slide. But the idea here is we're going to deliver security one little piece at a time. We're going to get that work flowing. We're going to move on to the next one, and we're going to keep it flowing. Every time we do one of these workflows, a sprint, if you will, we're going to add a little bit to our security story, and we're going to continuously enforce it forever from then on. We're raising the bar over time. So then the last piece here, this is an example, right? You want to work on your biggest threats one at a time. So let's talk about XXE. Right? We just added it to the OWASP top 10. It stands for XML external entities. And the idea here is if you accept an XML document from some untrusted source, the attacker could include a doc type in that XML document. And when your XML parser reads that XML document, they will process the doc type header. And guess what you can put in the doc type header? System commands? Yes. So it's a really easy way to send a command to an application to have it execute it. You can also include a URL that the XML processor will then try and get on the back end. So you can actually force a web application to reach out to another internal server inside the intranet. That's called SSRF. So it's like XXE to SSRF kind of flaw. So what do we do about XXE? Well, it's really not that complicated if you think it through. So let's decide that's a risk we're gonna deal with, right? We prioritize the risk, we threat model a little bit with, okay, XXE is our next thing. Well, then you choose a defense strategy. There's a couple things you could do. You could decide, well, we're not gonna accept untrusted XML. Okay, it might limit your APIs. Maybe you decide it's all JSON for us from now on. Okay, that's good. Or maybe you decide you're not gonna allow doc type processing. So most XML parsers, you can just disable doc type processing, and then you're safe. It's easy, right? Okay, so we choose a defense strategy. Then we go implement it. Maybe we have a standard library that we use for XML parsing. We could stand up a service that we use for that. Then we build some testing. We want to make sure that we're only doing our strategy everywhere. We'll talk a little more about this, but this is a positive way of validating that everywhere we handle XML, we're doing it right. And you may put attack detection in place. Like just because you're not vulnerable doesn't mean you're going to detect people who are attacking you with XXE. So you want that sensor in place because you want to know who's attacking you. And then the last thing is, you can go to monitoring. When you go into production, now we're monitoring, we're feeding, and if we ever see an XXE attack come in, we can respond. We can block their IP address, we can disable their account, we know something's going wrong, we can take a response. So to me, this is a great story. And if you implement this, then you've raised the bar for security from now on. and it's not difficult. I don't think we need security experts for very much of this. To implement this, this is the kind of thing developers can implement every day. Any questions on that?
Questions afterwards.
All right, that's fine. That's probably better to do it that way. All right. So definitely think of some really hard questions, because I really like that part of it. So I'll speed through the rest of this so we can get to that. So let's move to the second security way, okay? That was all about getting the work flowing, just breaking it up into chunks and getting it flowing. Let's talk about what we do to prevent going off the rails. So we're going to enable instant security feedback. So a couple things here. First, if you want to secure something, you got to know what's inside that something. Like, what's inside the circle of things we're going to secure. Turns out most organizations don't know where all their apps are, and they don't know what's inside, what software is actually running as part of those apps. They don't know what libraries they're using across the enterprise. That's all actually really simple information to gather. So what we've done is we try to implement something called self-inventory. And the idea here is you can add some code to each of these applications that will just report, what am I? So I'm this app, I'm running on this server, and here's the set of libraries and versions that I'm using. You report that all to a central server. So then, now you know, like, here's all my apps, and it's constantly up to date. So you don't have this kind of like, I don't know what code I'm running where problem. When Struts 2 comes out, you just go ask this thing, and within 1 second, it tells you, oh, well, here's the 5 apps that use Struts 2, and here's exactly what servers they're running on in dev, test, and prod. Say again? I don't think so, but let's take that offline. I'm happy to yes, does that create a vulnerability? It's really just one-way information out. And this isn't public, by the way. You don't have to publish this. This is just internal to your organization. So anyway, this is like a simple way to solve a problem that plagues most organizations. This is not hard. We just got to decide to do it. The second thing is, and I've talked a little bit about this, but we really need better threat intelligence. You need to know who's attacking you, what techniques they're using, where they're coming from, and what they're targeting. That information will allow you to prioritize your AppSec program. Right now, folks are just fixing vulnerabilities because they think they're important. But knowing what's actually being attacked is critical to that decision, and we're just blind there. So I strongly encourage you to put the sensors in place that will allow you to detect attacks in production so you know what's going on. Most organizations have a serious blind spot here. SIMs don't have information about whether applications are being attacked. They just take logs. Frankly, the only way we know what's going on inside applications is through log files, which are terrible. Log files have almost no security information in them. It's very difficult to tell whether you're being attacked by looking at logs. So this is actually a really important capability. This is, by the way, an example of the Equifax attack that happened just a few days after the vulnerability was released, but this is a real one from China. And you can see the expression there that it was just part of the content type header. It's just that simple. And then the last thing in this category is to create what I call an application security control plane. Now this is a little bit, we have network security control planes. Like, you can monitor all your devices and get security information about all your devices. We have nothing at the AppSec layer, right? When you put an application out in the world, it's just out in the wind. You don't know what's going on with it from a security perspective. So what I'm recommending is enhance those sensors so that now, no matter where the application runs, it's reporting. Sorry about that. I really want to get close to the screen. I know. We want to get telemetry from these applications as they're running about where vulnerabilities are, where attacks are happening. We should gather that information and feed it into some kind of central console dashboard where we know here's where the attacks are going, here's where we're vulnerable, and keep this happening in real time. That's half the problem, is just gathering that information. The other half of the problem is, what do we do with it once we gather it? Do we just put it in a PDF report and not do anything? I have a CISO friend. I said, what do you do with your vulnerability reports when you get them? And he said, come here. And he opened the door of his office, and behind it is a bookshelf filled top to bottom with consulting reports. It must have been millions of dollars worth of work. And I was like, are those all fixed? He goes, I don't know. We gotta do better than that, right? So the idea here is let's take this security information and feed it to the people that need it through the tools they're already using. And let's do it instantly, right? Instant feedback on security problems. So imagine a developer is typing along, they introduce a SQL injection problem, we detect it locally, we note it in our dashboard, but then we deliver it to them according to some set of criteria based on what he wants to, how he wants to be notified. Some organizations, it might be like chat ops. We might want that vulnerability through Slack or HipChat. Someone else might want it through Jira, or somebody else might want it right in the IDE. We need to deliver, we need to come to them and deliver vulnerability and attack information through the tools they're already using. We need to be in tools like Jenkins and Bamboo so we can fail builds instantly when there's a problem in code that gets delivered. And we need to deliver attack information directly to the SOC so that we can open up a new world of visibility to the SOC guys so that they can respond to application attacks. This is how we get this sort of virtuous cycle. We get information together, we get it to the people that need it, they can make improvements, redeploy, and we can quickly solve security problems without having to wait 6 months or a year. We'll talk a little bit more about that in just a second. All right, so that brings us to the third security way, and probably the hardest of the ways, which is how do you build that security culture? I've worked with a lot of companies over the years, and some of them have really good security culture. I'll say it's probably the minority of them, but other ones really don't. They're antagonistic. They fight security at every step. But what's weird is they're doing all the same things. Like they're both types of companies are doing pen tests. They're doing code reviews. They're doing architecture review. They're doing threat modeling. They run tools. They're on paper, they look equivalent. And against the BSIMM, they look equivalent, or OpenSAM. But they're really completely different in terms of how they think about security and how successful they are about security. So I want you to really think about, this culture question is tricky. A couple ideas on what you can do to improve security culture. So the first thing is, I would love it if organizations would migrate from a negative way of thinking about security to a positive security. Let me tell you what I mean. So most tools and most pen testing basically looks for a set of negative behaviors in applications, like SQL injection. That's a pattern of execution in an app that you shouldn't ever see. Well, there's a million different ways of writing bad patterns of execution, right? But if you decide as a company, like, we are only going to use parameterized queries, okay, winner. That's a positive way of thinking about security. And guess what you need to test is one thing. It's way easier to test that one thing than it is to test all the possible ways of screwing up. So, right now we're trapped in this tight orbit around planet negative. We've got, negative policies, we got negative testing, and we're just trapped in this patch and fix cycle.
With your permission, I'll tell you why. Because I think you're absolutely hitting the point on the nail. The challenge that I find is that if the top decision maker is not technical, who needs to see the value of why they need to change their mindset, that change of mindset is going to come from the technical expert. Technical expert does not want to speak, with respect, the business language. Neither one of them can communicate. They may be both speaking English, perhaps, but they're not talking to each other.
Yeah.
And they're unlikely to talk to each other because one cannot make the business case for the change of mindset. The other one doesn't understand the technical challenge of switching from a negative to a proactive.
Well, I'll tell you what.
Would you not agree with that?
I think that's most of the way. I think there may be some other reasons as well, but I think that's. Sorry? Oh, what do you want me to do?
So if anyone wants to ask a question, I'll bring one.
Oh, yeah. Sorry, I can repeat the question if you want. I mean, basically, the question was. Maybe I can. I don't know. The question was basically like, does this phenomenon, the fact that we focus mostly on negative testing, result from miscommunication between security folks and business leaders? And I think that's a big part of it. But what I will say is that that's on us as security folks. We've got to come I'm thinking of that scene in Hitch where Will Smith kisses Tom. We got to come like 99% of the way to the business leaders. We have to learn how to talk to a way that they can understand. And they're going to keep going. Like, they're going to keep building code. They're going to keep deploying it. They're going to keep running the business. It's our job to figure out how to convince them to do something better. This is a simple way to massively reduce the scope of what we do. And if you remember that slide at the beginning, it's not like we're going to instantly get twice as many security folks. If we did, the industry average skill level would drop by half anyway. So it's not going to work to just explode the cybersecurity workforce. We need to do something to work smarter, not harder. And this is a really key way to do that. I've worked with organizations that have done this, and they have systematically eliminated the OWASP top 10. They never have SQL injection, never. They've almost eliminated cross-site scripting. They've got standard defenses for CSRF, and well, it's not even a top 10 anymore. But they are actively working on this approach to eliminate flaws, and it works. Different kind of culture. So the next thing is, I want to focus on how do you accelerate the evolution of your security story. Remember the beginning, I said you got to have a story. Well, your story could be like one control, right? It could be we're going to use prepared statements. That actually would be a better security story than a lot of companies are operating right now. Like the whole story, that would be better if they just eliminated SQL injection. But thinking about how do you evolve that story over time, if your feedback cycle is 1 year, you're doing an annual pen test, you will never evolve your story, right? You'll just, at the end of the year, you'll start over and you'll do another pen test. It'll start from square zero and you won't build anything. But if you continuously do cycles on small pieces of the problem, well, let's add SQL injection, and then maybe later we'll add XSS, and then we'll move on to authentication and access control, encryption and logging, and so on. You can evolve this story over time. Some of the enhancements are going to be like countering new risks. Some of the enhancements should be like, let's just make it simpler. Complexity is the enemy of security, so you constantly want to think about simplifying your security story. The key to advancing in security is how fast can you iterate this, and it's up to you. You can go as fast or as slow as you want, but if you go too slow, you're just going to be overtaken by software every year. So you got to move pretty fast just to keep up. But this is a way that security folks can communicate with development teams. They can say, hey, you know what? Our next thing we got to do is this. Let's everybody heads down. We're going to focus on this next thing and get it done. It's a different kind of culture, though, right? It doesn't sound like the culture in most organizations. And then the last thing is I'm going to talk about promoting security in sunshine. So in the United States, our government, we have this idea that we should govern in sunshine. There's actually laws about this. Now, whether we practice those things fully these days is probably questionable. But the idea is sound, that we should do security in sunshine, I think is really important. And let me talk about this for a second. I'm going to talk about this cycle. People inherently trust software, which leads to blaming behavior, which causes folks to hide security, which then actually feeds back into this blind trust because you don't have the information that you need. Let me make this a little more visual. People trust software with no reason to trust it. Anybody here bank online? Anybody have any reason to trust the software that they use to manage their money? Do you know how it was tested? Do you know who wrote it? Do you know if they were trained? Do you know what components they use? Do you know how often it's deployed? Do you know what they do to respond to vulnerabilities? Do you know anything? No. You blindly trust it because your bank said, it's awesome. That's crazy, right? We blindly trust software. In fact, anybody ever installed a piece of software that they just download off the internet on their computer? Liars. Some of you, I know everyone's done that. I hear this from people all the time, and they say something like, well, yeah, I was a little worried about it, but I installed it and it didn't do anything, so I guess it's fine. Holy shit. Like, it couldn't possibly be doing something in the background, could it? Or like, yeah, I mean, it's crazy how people trust software, and it's totally blind trust. So that leads to blame. And we've got a serious culture of blame in application security, right? security folks trumpet, like, I found a vulnerability, and developers don't know how to build code. And like, it can, in some organizations, it can get really hostile. Anybody work in an organization where there's hostility between development and security? Oh, thank you. That's some honesty. Thank you. I appreciate that. It's actually a real challenge. And this blame, it ends up focusing on the people that are not responsible. Like, often developers get blamed for security vulnerabilities, and it's not their fault. Developers have a full-time job, and it's super hard. They've got to keep up with an unbelievable amount of new things every day. And just because they saw some jerk train them for 3 days, a year ago, doesn't mean that they know security. So it's really not fair to hold them accountable. The problem is really the game. The game is not set up to help them succeed. If we do our job and we're delivering them the information they need in the tools they're already using, we can help them be successful, but we shouldn't be blaming them for getting it wrong. If the blame belongs anywhere, it's right on security experts for making this too hard. And then the last thing is that blame leads to hiding. And I'll just go out and say that not every organization has been fully upfront about every breach, Uber. Right? You get breached, and not everybody's going public right away. We're in a weird era of disclosures about sexual misconduct in the United States and maybe elsewhere. And I feel like the same thing is like at a tipping point for security folks. Like, if you get breached, you better disclose. But this problem of hiding security, even inside the organization, I see this everywhere, where vulnerability information isn't shared among developers, among teams. It's hidden, right? Anybody got a rule that says, like, you can't put a vulnerability in email? Like, you have this risk register that's got massive access controls around it so nobody can see what's in there. That's actually really problematic. And I'm pushing the envelope here a little bit, I know, but I encourage you, make that stuff visible inside your organization. Celebrate every vulnerability. Allow yourself to get that information to the people that need it so they can fix it right away. And don't put it in some risk register that's where it's going to fester for 2 years with nobody fixing it. Get it out there, get it fixed. Vulnerabilities and attacks are opportunities to make ourselves stronger. In the Vin Diesel, like, it takes 500 fights to get tough. Like, that's how kind of the tough we need to get. So we should celebrate attacks. And some of the HackerOne and Bug Bounty kind of programs, I think those are actually really helping that culture go on. You celebrate attacks, use them. So this is sort of an important part of getting a good security culture in place. All right, so that's the 3 ways of security. Hopefully it challenged you to think about this a little bit differently. I want you to go back and really think about, how do you get security work flowing in your organization so that you're delivering something real, not just abstract concepts like negative risk or whatever. Really deliver something like a document or proof or a security story that you can articulate to people. Maybe it's a dashboard or a website. Make sure you get that feedback flowing so you don't go far off the rails. And then the last thing is work on that culture. And it's hard from one person's perspective, but that's where it starts. We're it. The folks in this room, in this organization, that is it for application security. There ain't nobody else coming to help. We've got to make this change happen together. So a couple of closing thoughts here. I think a lot of folks kind of think about, how do we make software secure? And how do we build software securely? I actually want to turn that question around and say, how do we make software security something that you build? When you make it concrete, it becomes something that this machine can deliver. And then you can work on flow and feedback and culture and so on. So I'll stop there and open it up for questions. I love any kind of questions on any topic related to anything, really.
Okay. First of all, let's thank Jeff for his amazing talk. Right, guys. So I know there are lots of questions that I received online. So because we have Bristol online, I think I'm going to give priority to Bristol folk to ask questions first. Right. So for this, Jeff, we need to start streaming. Can you stop sharing your screen?
Oh, yeah, yeah.
Testing from Bristol. Can you guys hear us?
Yeah.
Okay, I'm hoping we have questions for you. Thank you very much, Jeff.
There's a
That's
security
really cool.
update installed. Thank you, Mac. Okay, so I've got
Zoom.
Okay, so we have some questions from Bristol.
So I just need to turn off.
Yeah, turn off the sharing.
Back to meeting. No.
I'll pass that.
It's like disabled. Oh, stop share. There we go.
Sharing.
Sorry.
Yeah, excellent.
That's
Okay.
like my first time. Thanks. I'll get out of the way. I'm gonna.
Okay.
Step
No.
down.
Stay. If you, because people can see you. Yeah, the camera is just there. Right. Okay. Bristol guys, please ask your questions.
Hi, Jeff. How can an organization start a threat intelligence program?
Yeah. So there's really two major sources of threat intelligence. One is internal, by watching who's attacking you and what techniques they're attacking you from. And then there's external sources of threat intelligence. And there's in that there's kind of two categories. There's like attack information, which you may be able to get from like FSI-SAC or Solterra, one of those kind of sources. That's really not going to cover application security. So I would recommend OWASP as the other kind of information that you might get about new threats that are out there. Maybe go to conferences like Black Hat or DEF CON and follow folks that do that kind of thing on Twitter. Those are the kind of external feeds that I rely on. And I wish there was a better story there, but frankly, we don't know very much about what's going on in the application security world from a threat perspective. I'll tell you this, last month, we observed a sharp uptick in padding Oracle attacks. I don't really know what's driving it, but if you all didn't see that too, then you're not measuring it, right? And my guess is that we're the only ones in the world that saw it, because most people don't have the kind of sensors that we have. So, I feel like we need to do a lot better job about figuring out what's really going on. And we're just at the beginning of this, literally just scratching the surface of this problem. Great question, thank you.
Bristol, any more questions from you, please?
A question, 1 second.
Hello. So I work in the operations space. So I guess my question's really around monitoring and observability of this stuff. So I think we've got some good tools in the operations space to see what we see on the platform in terms of is the application performing well. You mentioned there's a problem in the security space there. Is that a failing in tools or how we build the application, or what's the reason for that?
Well, it could be tools. I think it's probably a tool problem. You could use things like App Sensor to try to build attack detection into your application, but that doesn't scale very well, right? Like, are we likely in the next 5 years to get most applications to have attack detection built in? Probably not, right? Like 90% of the applications are legacy applications that are out there. So like, how are we going to add it to them? So we really probably need an automated solution to detecting attacks at the application layer. So yeah, we need better tools. I'm trying to help there.
Okay, I have a question as well from Bristol. So I'm an application developer at Just Eat. I'm not I guess I wouldn't call myself a security expert. I care, but I don't do it day to day. Should I have a broad understanding of security within the domain of code that I work in within Just Eat? So we have a really big tech estate. Should I care about the small part of the architecture that I work on and have a broad understanding of security in that space? Or should I care about a few important parts of security across the whole estate? Because doing both is kind of impossible.
Yeah, that's a really interesting question. I mean, I think a lot depends on how you decide to structure security internally and sort of how your teams are set up. But I will say this, I would focus on the things that matter most, right? Like, don't worry about system out print line, worry about SQL injection and command injection and access control problems and things like that. So, worry about getting visibility for the things that really matter before you worry about things that, like clickjacking is a good example. Like, it's not a huge deal. It's way down the list for me. So, think about what it really means for your enterprise for each of these kinds of threats. And then, actually, so from an operations perspective, I don't think that doing operations on application security kinds of attacks is really very different from doing the kinds of things you do for network attacks. If we have the right sensors, you'll detect an attack, it'll report into the SIM, it'll show up on your maps and dashboards and cause whatever PagerDuty and VictorOps alerts to go out, and you'll get an alert and you're gonna have to deal with it. And probably that means like, oh, well, I don't know what this is. Let's talk to the development team and say like, is this a real problem? And help, bring them in to help you in triaging what the actual, damage done is. But not a tremendously different workflow, I guess is what I'm getting at.
Hi, I got a question.
Yep.
Sorry, I agree with what you're saying that the developers aren't great at the security thing. We see that a lot. They get a bit of training. They do things great for a little while and then everything sort of falls apart. But how do you sort of address the creating this culture of security and increasing the appetite sort of at in the senior management levels when they've got the culture of it will never happen? Yeah, I understand it, but it's not really going to happen, is it?
Yeah.
And then you need to build that into the whole workflows that you're talking about and create that. How do you break that kind of cycle?
Yeah, so on the first part of your question, like I've trained thousands of developers and almost across the board, they are passionate about security. They're interested. They want to do it right. They try to learn it. So again, I'm not about blaming developers at all.
I used to be one. So.
Okay, good. So
I've been there.
But on the side of convincing management to invest in this, there's a number of strategies. The one that I have found most successful is to gather real data about vulnerabilities and attacks. And you don't have to do it across the entire portfolio, but pick a subset of applications that you can manage. It might be a small number if that's what you can do. It might be a big number, but gather real data and capture it and then extrapolate it. Say, look, we looked at 5 apps and here's what we found. We've got a ton of vulnerabilities. Here's how they break down. And we're actually being attacked a lot. And here's some numbers around that from different countries. And then help explain to them the significance of that. Like, what does that mean? And then extrapolate it across the whole portfolio and say, look, that was 5, but we've got 500 apps out there. So our attack surface is huge. And give them the data that will allow them to justify the investment in improving security. I actually think, doing security smart, some of the ways that I've talked about, are not necessarily much more expensive than doing security the kind of inefficient way that we've been doing security. So there's a lot of opportunities for cost savings here as well. And really, let me follow up on that for just a second, right? So if you do security the traditional way, sort of find vulnerabilities well after they were introduced and then scan for them or something and then try to go back and fix them, they're very expensive to fix. The cost of finding a vulnerability is like $1,000, but the cost to fix it is like $4,000. So even if finding all the vulnerabilities was free, like even if I could hand you all the vulnerabilities in a big database today, the cost of fixing it is where all the cost is. So if you can go to the executive and say, hey, look, if we do this and push vulnerability discovery way left into the developer's environment so they can fix it as part of their normal workflow, we can eliminate most of the cost of security. And so, there's a lot more efficient ways of doing things. Thank you.
Thank you.
Okay, guys, because we're running out of time, what we're going to do now, all the audience in London, can you please ask your questions during the break that we're going to have? However, I hope you are using the app. There are a lot of questions asked using the app. So I'm going to show the questions on the screen, and it's up to Jeff to pick them and ask them about 15 to 20 questions. Okay, so Jeff, if you turn and look at the screen, you will see the questions now.
Yeah. I have no idea what comes after DevOps and DevSecOps. Probably something faster. Good question about AI and machine learning. I am not a fan. So let me tell you why. So look, to do machine learning, you got to have a big data set, right? And to have that big data set, you got to pretty well understand the problem, right? Like you'd have to have like a zillion examples of SQL injection or something like that, right? Then you could train a neural network to kind of find it. But if you really understand the problem, you should actually fix the problem. Like, you know how to do it. You don't need a neural net to identify problems that you know about. So that leaves the problems that we don't know about, right? Like the unknown things. And the problem there is we don't have a data set. How do you have a data set of shit you don't know? And so we end up with this model where AI doesn't really help us on either side of the equation. So that's sort of where I am on this. There are uses, but they're narrow to me. I think there's a lot of blocking and tackling that we need to do before we get to stuff that AI can help with. Let's see. If only 8.5% of vulnerabilities are in libraries, do you suggest not to use them? No, absolutely not. I think you should use libraries. You should just remember that when you adopt a library, you're adopting a responsibility to keep it up to date and to have a mechanism in place to respond if there's a new vulnerability that comes out. Why does the top 10 not change in all these years? I don't know. I mean, it's hard to do some of this. Like I think DevOps actually is an interesting opportunity for us to make real progress against this. But like trying to do it with experts, we can't get in front of the problem. It's just we haven't had the scale. But DevOps provides the automated infrastructure that we can add security to and make much better progress scaling this up. We could have never established that infrastructure by ourselves as security. So we can stand on the shoulders of giants a little bit. Let's see. Even for one vulnerability, the 3 ways is a lot of work involving the business, test, and ops, all different teams. How can security bring all those things together? Well, yes, that's a good question. It's not necessarily easy. This is going to take time to adjust how you do security. But I would do it for one, and try it. And it's essentially the way that people start with DevOps. They start building one sprint, one flow, and realizing the value, and then building on top of that. But it's not easy. Particularly, this question assumes an organization that's not very far along in their DevOps transformation. If they are, then those would be all kind of, they already would have brought those teams together, and you can take advantage of that. So, maybe the best way is to start DevOps. Let's see, let's go down to the bottom one here. It says, do you see RASP more as a detection facility or protection for flaws that are shipped to prod? And really, it's both. I mean, if you can detect an attack, you should probably be able to block it, right? So those two capabilities are very tightly linked together. The trick is you have to be sure. You have to be really sure that it's a real attack. If you block stuff that's not real attacks, you break apps. And if you break apps, you're on the street. So the idea behind RASP is moving from outside the application where a WAF runs, where you have limited information to make a decision about whether something's an attack. It's almost impossible to say for certain whether something's an attack. If you just look at the HTTP request, move it inside the app where you have all the context, and then you can make an intelligent decision about whether something is actually an attack and decide to block it only if you're sure it's real. I think of RASP like ASLR, right? It's a defense that's built into the application that makes vulnerabilities harder to exploit. So for buffer overflows, we do address-based randomization, and we can eliminate the ability to exploit those vulnerabilities. The same thing with RASP. We can build into the application the ability to identify attacks and eliminate the ability for them to exploit vulnerabilities. But the visibility is really important too. I mean, so you got to know. Let's see. Was one of your key takeaways that 80% of known vulnerabilities could be trivially eliminated through better supply chain governance? I don't think that's right. I hope I didn't say that. I don't remember saying that, so maybe I'll take that one offline. And if you want to follow up on any of these questions, you can hit me on Twitter or send me an email or whatever you want to do it.
Guys, can I just say the questions will stay on the board, so during the break, please carry on asking questions. So at least it will provide visibility to your chat.
Let's see. So I think that's probably good. I mean, these are questions from folks in the room too. So isn't the problem with IAST and RASP that they're tied to a small number of languages, frameworks, and runtimes? Developers change quicker than they can keep up. That's a good question, and it is a challenge for technologies like IAST and RASP to keep up. But I don't think there's really any alternative. Currently, contrast, we support a pretty broad range of languages. We do all the languages that run on the JVM, like Java and others, .NET, Node.js, Ruby, and Python, which covers, if you think of sort of the pie chart of what languages get used to build apps, particularly apps that people care about, that's a big chunk of it. But I think it's, so let me back up. I totally believe that in the future, every application is instrumented for security. In the real world, we instrument things that are complicated, right? We instrument cars and airplanes and nuclear power plants and factories. We instrument factories like crazy. Heat sensors, vibration, light, temperature, everything. And if anything goes wrong in a factory, we know instantly. Now, software is probably the most complicated thing that man has ever built, and we have completely shit instrumentation. Like, all we've got is logs. We know barely anything about what's going on inside an application if something goes wrong. That has to change. And so I believe in the matter of a few years that most applications will be instrumented for security and other things. And going long term, I think that includes all kinds of instrumentation. You're going to have instrumentation in blenders and dishwashers and airplanes and satellites and everything, because it's crazy to run something super complicated without instrumentation. It's just nuts. So that has to change. And sort of IAST and RASP are on the forefront of pushing that envelope.
Okay, I think we have to stop at this point. So thank you very much, Jeff. Let's thank Jeff one more time. Yeah, that was a good one. Okay,
thank you all. Appreciate it.
We're going to break for 5 minutes, right? Comfort break.
Thank you from Bristol as well.
Yeah, and then 5 minutes, David will present his talk on myths about cookie security.